Understanding spanning trees.
A spanning tree is a fundamental concept in graph theory. It is a subgraph that includes all the vertices of a connected graph, but only enough edges to form a tree. This means there are no cycles and every node is connected using the minimum number of edges. Spanning trees lay the groundwork for efficient network designs and algorithms.
Key properties of spanning trees.
Spanning trees have specific properties. For a graph with n nodes, a spanning tree will always have exactly n-1 edges. Removing even a single edge disconnects the tree. Adding any edge would create a cycle. These properties help ensure efficient network structures with no redundant paths.
Why are spanning trees important?
Spanning trees are essential in network design, particularly for computer networks and telecommunications. They help avoid loops, minimize wiring or cable use, and ensure all devices stay connected. Networking protocols like the spanning tree protocol use these principles to maintain stable and loop-free networks.
Examples of spanning trees.
Imagine a triangle-shaped network with 3 devices linked to each other. The original network has 3 connections, which forms a cycle. By removing one connection, you create a spanning tree. Each device is still connected, but now without any loop. This simple example shows how spanning trees eliminate redundancy while preserving connectivity.
Algorithms to find spanning trees.
These algorithms, like Kruskals and Prims, are popular methods to find spanning trees, especially minimum spanning trees, which have the least total edge cost. These algorithms are widely used in optimizing networks, designing circuits, and solving routing problems in computer science and engineering.